Hello, everybody. So tonight starts week 4, almost halfway. When this module ends, that's 4 out of 8 modules. So the class is moving along pretty quickly. We still got a few things to cover. One of the ones this week, there's not quite as much to say about it and talk about it later. Because one of the things this week is working with strings and basically saying stuff about that in lecture time would be rattling off the same list that's in your textbook. So we'll talk about a few things, see some quick examples, but there's not as much to talk about it with strings. We'll spend most of our time looking at our collections, but there was still a little bit left over from last week with file writing that we didn't quite get to, because that's an important aspect. I want to make sure writing files make sense. We looked at basically just strike the syntax for sending words to a text file, and then quickly talk about our code is just a text file. And that's something you'll see a lot in our world is whenever software needs to do very complex things, it's a lot easier to write a program that will write the program you actually want. Because if there's a lot of things to keep track of, like lots of variables and lots of different dynamic things that are easy to get lost in when you start putting your variable names and everything to get and functions together. It's a lot easier to set up instead of doing that, make your algorithm and organization scheme, then have a computer write the actual script that you want to run. If it's going to be very complex to get through. That's a common thing. That's way down the road for y'all. So but you can start doing a small Python script. So things that you know would work in a Python script. Try writing a file and sending that to the file. Or an HTML page. Set something up. That might be a good project for the class where with the GUI you drag your mouse around and put different text in different spots on the page. And then when you click a button, the GUI automatically writes the HTML file that corresponds to that. So a program that writes another program, we'll look at that. But the big thing that was still missing was actually persistent data, saving the data from a program. We have a couple ways to do that. All our textbook covers is sequential files, so we'll look at that real quick. I'll do it. I was thinking do it 3 different ways, show you the syntax for it and kind of what's out there. Sequential files work, but there's better ways to do it than that. Just the order that we write it in the file. So that's where the name comes from. The first one is sequential files. I'll go ahead and write a note on the board. Yeah, I was going to try using this new one, so I'll make the notes there. Which this might actually work pretty well because to write on this, I had to grab something, so I just grabbed Jamboard. So our basic type of organizing data into a text file or any type of file, we're going to look at text files here so that it's still human readable. So I can turn around and face you all still on the camera somewhere, is what's called a sequential text file. And like the first part of the name indicates, it's based off the order, the sequence that we write things in. So keep track of order we write. Write the data in. Then read it back in the same order. So I think it's going to take me a little bit of getting used to a little while to get used to the new board, but also that's on Jamboard, so I can just send the notes out afterwards. not quite the same as a marker. I'll get used to that. But that's our, actually, I bet that might have worked better as the second screen to this. I might try that next time. Do that the second screen on my laptop, because that's the one I'm usually sharing the screen from. So to look at this, let's look at that example we started building up. That way we're seeing it in place. And syntax-wise, it's just writing text to a file like we saw before. So I'll open up Spider. And I also emptied out the repository. So why don't I do it this way? So along with doing that in a terminal, last week we saw grabbing stuff from GitHub from the terminal instead of just downloading it. There's also a GUI that comes with it. They have some software that it's a good idea to install, and it adds more security features than the original version of Git, which is what all terminals know about. And when you install that, there's also a GUI one, and the GUI has some nice things. So to get our files, I'll use the GUI this evening and point at the one button that the GUI is definitely the best place to see it. So we know these files are on the website for GitHub, //github.com. And I know the name of it. It's on my account. And then there's an SDEV 140-fall 2022, which is a repository. So I'll go ahead and type .git because I want to grab that. Actually, I think I can leave the Git off here. Go ahead and type it. And when we want to put it in now we need a place for it to go. So the source is over there online on GitHub, and the target is here locally. And this one's a little non-intuitive, a little different than what we might be used to, because with the browse button, we pick the parent directory. We pick the parent directory to put it in, but then we have to add one more folder, and we have to type the last folder name. So if you use the Git graphical user interface, the browse button goes to the parent directory, and then we'll create another folder there. This checkbox won't hurt anything. There's no sub. When I go ahead and clone that, it goes out, grabs everything, and we have a GUI thing here. And if I go in here, you can see it created that folder and then grabbed all those files from GitHub. So that's one way to get it. And then there's 4 steps. So unstaged changes is everything we've changed since we pulled that down from the repository. Oh, not on the camera there. Since we pulled it down from the repository. And then we hit rescan, and that'll show us all the changes. Then we stage the change. So that's kind of like, I would have used something more like backstage. So like backstage getting ready to be shown on deck for baseball analogy, but it gets everything that it's ready to change. And then we can hit the commit button that we approve those changes and push it right back up to the repository. The big thing about this though, with the GUI, there's lots of buttons. So when you're checking things out, you want to click on the different buttons. But under the repository button, there's this visualize the history. Well, all branch history, but I only have one branch here. I've only made one version of our course thing. Done alternate versions when y'all weren't looking, it's just the ones from class. But the desktop GUI has the best version of the history. So we can go back to every single thing that's happened there along the way. So when we upload a file, it doesn't overwrite the file. It makes a new version of the repository so we can get back to any of the earlier ones. And you see all the green pluses and There's no changes. If there was anything that had actually changed, there would be red minus signs showing us what lines were taken out, what lines were put in, and we can keep track of every single thing that happened in the entire history of that project. The little desktop GUI has the best version of that. And you get that from, if you download Git, it's actually Git SCM. If you remember those letters, but if you just search download Git, that'll be the top option. You just download them appropriately for your system, whatever system you're on. But that gets our files down locally, so then I can open up that last version of the thing we were working on, which is payroll 210. Looks like the last one I see on here. So really, we don't need the multiple versions. GitHub is keeping track of the multiple versions. We need an earlier version. We just look at the history and pull that earlier version out. That camera is in a different spot than I'm used to, so I keep stepping off my normal talking spot, and the camera's not looking at me anymore. I wanted to try the new board. There are advantages and disadvantages to everything, so I want to at least get used to it, figure out what I need, what adjustments need made, as opposed to what I'm used to. So the big thing is the data, the persistent data, right? We need 3 pieces of data here, and we're getting them from inputs right now. But that's a bit unnecessary, because how many of those 3 things are going to change? Is the employee's name going to change week to week? I see head shaking in here. Hours worked is different. So that one will be, we need to grab that every time. And then how much they make, that's not going to change every week, right? They'll change eventually with a raise, but if it only changes once a year, it's probably a lot easier to change it in the database than the actual, than retype it in the program every time. So 2 of those we don't even need up here in this method. So I'm going to comment those out. And now we only have that one input we need. And I'm going to write another method to just grab all of our data from the database. Everybody saw arrays in SDEV 120, right? That's our lecture material for maybe the end of this evening, but probably Wednesday. So I do need to jump ahead a little bit. I want to create an array. Okay, yeah, so everybody's seen arrays, so I'm just going to go ahead and use one, and then we'll talk about it, because I just said array twice, and we don't have arrays in Python. But that's getting into the technicalities and the stuff that'll show up in lecture. We have lists, but list is a word that shows up in English a lot. And a list for a computer is not the same as a list in like a grocery list or a to-do list. A different meaning for that word. So we still say array, kind of like we say Google instead of search for it, or instead of use the search engine. So I'm going to set up a couple of arrays that we can use to read our data in, and then look at different ways we can store the data. So I'll set up an employee array, and yeah, that'll work for now. And then we'll nest some arrays inside there, so it's actually a 2-dimensional array, and then we'll have the name. We'll keep the name and pay rate in a file. So that's something we can easily do. So we need a function to get our data. Get data sequential file. I'm going to write pass for a second, because before we do that, we probably want to write the data to a sequential file. So define, I'll put read. read sequential file, that's a better name. Oops. Read a sequential file and write a sequential file. So I guess the first thing is we need to write our data. So at one point we need to ask the user for the data. So this is where we would ask. So I'll set up some file writing like we saw last week. I like to use the with keyword just for at least in my mind, it makes sense for what I think of as the basic Python syntax. We have a keyword, something unique to our situation, which is we need to open a file handler. So with open employees sequential.txt, so a text file, and I'm going to open it for append mode. That way we can keep calling this method. We don't need one to start doing stuff and then another method to add individual things. We can just set one method, and if we need to add more employees, we can add more employees to it. We don't have to redo it every time. So append mode, so we're just going to add to the database as to-file, and I use the words the reference names to-file and from-file most often. It seems like an easy way to keep track of which direction it's heading. So now we just need to know if there's another employee. So I'll set up something that says maybe more, and that'll be an input. Is there an employee? Is there another employee to enter data for? So ask a quick question there. And while more does not equal no, well, not more equals no. And this is one of the string things. So like the strings lecture that we're going to kind of skip over because it would just be reading a list, the same list that's in the book. There's a bunch of methods built into strings, and we've already used a couple of them. Like to lower. We don't know how the user is going to enter the letters N-O. Could be all caps, could be all lowercase, could be capital N. Could do a lowercase n and a capital O. That seems a really odd way to enter it, but it could happen. So whatever they give us, we'll make it lowercase. And if that's not no, I guess it would, yeah. Or we could just say while it is yes, I guess. Multiple ways we can do the list. My first thought was to put it as yes, no. My first thought was to put it in as not no. I guess not no is the same thing as yes, because I think about it a little further. So while there's another one to enter, we'll bring this in. So I'll copy this up here. Tell me who, well, in this new situation, it's kind of like a secretary doing it, right? So tell me who it is then, instead of the cheerleader prompt. So then we have that input, and I'll copy the other one. Copy, Control paste. And how much do they make? Which at this point we could use their name and rate of pay to spell it out. Remember, those are local. Those would just be local variables, so they will only exist inside that while loop. And then when we're finished looping, garbage collection will clear them up. or actually when we come back around for the next pass of the loop, garbage collection will have already cleared them up, and we can reuse those names over and over again. So keep an eye on the scope of the variables. And then if once we have those numbers, we can write it to a file. So what I'm going to do is write it to the same line of the file. Maybe with some sort of special character. Actually, I'll do it in sequential lines. I'll do it on different lines. And one data point per line. That's really what a sequential file is. So what I was thinking, I was almost manually doing a CSV file. We're going to look at a better way to do a CSV file in a moment. So basically the sequence, where the origin of the name sequential file comes from, is we pay attention to the order. So every line in the file gets one data point. As long as we know the order that they're in the file, we can set our program up to read them back in the same way. So then we can say toFile.write. We're going to write name plus a line feed. And here earlier, we were getting ready to do math with that number. So we had to turn it into a floating point number, but it's coming from a keyboard, which means it comes in as a string. So, and then to send it to a text file, we need it as a string. So we don't want to cast it into a number right now because we're not doing any math with it. All we're doing is moving it from the keyboard through RAM and then over to a text file in storage. So we don't need it in a floating point number to do math on it because we want to keep. Otherwise, we would have to cast it back into a string to send it to the text file. toFile.write rate of pay plus a line feed. And if we're using commas in the print statement, I would try to warn people against that because that is a very unique thing that only works in the print statement in Python. So that only works through the console. Any place else we need to build a string, we have to use concatenation. So it's much better practice to just use the concatenation everywhere instead of that comma thing, because that's unique and we can't even use it across all of Python. So that we'll get those values and write them to a file, and then we'll ask if there's any more. And then this is why I chose a while loop here. That's when they're interchangeable, but our general rule of thumb should be that if we don't know how many times it's going to happen, use while loop. For loops are for when we know exactly how many times it's going to happen. If we know there's a definite name. Like, how many employee names are people going to start entering? We have no idea, right? It could be a company could be a small family company. So the 5 people in the family, 2 or 3 spouses, and just a very small one, or it could be 10,000 people. We don't know how many they're going to enter. We just know we're just going to let them keep entering until they're done. So that's where we want a while loop. So while our condition is true, do this stuff again and again and again, and make sure you have something that will eventually make the condition false. I guess I can clean this up now. Always comment out when you go to make a change. So now all we need to return is HW here. And then when that comes back, we only have one place to put it. Oh, I just said not to do it that way. So always comment a line out, then I'll push Shift and N to copy the rest of it, and make the changes on somewhere else And then if the changes work, then delete the line, the original one. You always want to be able to get back to the original if your next couple steps don't work. Right? If you go to make changes and it doesn't work out like you thought, you want to get back to the last thing that worked and then try a different change. You don't want to just keep randomly making changes until you get the one that works. So always comment and then delete later. Because now we're going to write stuff to a file. And when we read from that file, we can keep track of the data points in that file, actually use it for database structure. We use database when we're talking about relational databases most often, but in database generically means anything that it just means the data held in storage. So technically our folders and files in there, the directory structure, that is a database. It's a hierarchical database. But even if you know that technicality, you would never actually call it a hierarchical database. We call it a directory structure, or just say folders because that fits better in English sentences. But it is technically a database, so I'll use that word some tonight. So we set up our database. We have a sequential text file based database. So now we can read from it, and we know we can do that by going the same way. So I'm going to use the open syntax, which is creating the same thing as your book, right? Up here, in the way your book shows you, you would do to_file equals what this method returns. So the as word kind of turns around our assignment. And when we use as, we make assignments going left to right instead of right to left like we're used to with the equal sign. But so that's doing basically the same thing. And you have to remember to close it at the end. With word, when we use with, that includes some basic error handling. So it'll deal with some small hiccups that are the obvious problems that could arise. With has those built into it, and it will close it on. It will already has closed the file built into it. So it cuts out a couple of steps for us basically. So same thing down here. We're actually going to open the same file. So I'll just copy it from here. I'm actually going to copy almost all of that. I'm just going to do it a piece at a time. So instead of for append mode though, now we're reading it, like the name indicates. Read from that as from file. And now we'll do like we saw last week where we just looped through all the lines in the file. So from file has a bunch of lines. So for line and from file read, we'll read the whole thing in, put that into a bunch of lines, and now we can deal with each line one at a time. And our lines are going in a certain order. We know the order they're in, right? So if we just read them all back into that array, our first line is going to have a name, and that's index 0. Right? First line is going to be index 0 in the array. Then the second line will have a rate of pay. So index 1 has a rate of pay. Then the third thing will be back to a name, which is index 2. So 0 and 2 have names. Then index 3 is going to have a rate of pay again. And do you see a pattern forming that we can tell based off an odd or even index whether we're going to have a name or a rate of pay? So that's our sequence. We created a sequence we can use as a pattern to bring that data back in. So I'll just I'll call this employee data and use that sequence. So for each one, we want to read it back in. So employee data, and we're going to add it to that array. So dot append. And what do we want to append? We want to append line. But every line has a line break, right? We don't need that line break. That'll cause problems. So we actually want to stop one before the line break. In this particular textbook, there's a thing, a dot trim method they keep using. I have no idea how long that has been in Python because I never saw that. And there's actually left trim, right trim, and trim. I never saw that until this textbook. Another way we can do that relates to the skimming over this string lecture this week is a string is always an array of characters. We can always use a string. We can always treat a string as an array of characters. And that is across the board in programming. That is the very definition of what it means to be a string. It's an array of characters. So we can treat that, what we read from that text file, as an array and just drop off the last index. Python has a nice little notation for that. So in the square brackets, we can also do from and to indexing. So we could start at index 0, start at the beginning, and go to the length -1, which Python also allows us to do negative indexing. So the things 8, say we have 8 elements, so we have indexes 0 through 7. We could say index -2 is another way to get to index 5. So Python does allow negative indexing. And we know that because of how we wrote it, our very last character is a line feed. So if we just leave that off, if we leave off the last one, then we'll just read that data back in without that line feed we added at the end. I like to show it that way instead of the trim method because that is the way that works in every programming language. You don't have to look up any method name for anything. Because you know that a string is always an array of characters. So we'll read all that back in, add it to that array, and that's all we need to do there. That gets our data to a file and then reads it back in. So the only change now is adjustments in how our program runs when it starts off. So if I scroll down here, we get those numbers, and the problem is we don't have a rate of pay to pass in here, but that's in our array now. So we'll actually want to loop through the array. So what we ask here, we don't need to do that anymore because we know exactly how many things there are. If I hit save yet, I don't think I've hit save. I need to save this under a different name. Save as 2, 2, 0. Oh, this is a big change. So this will be 3, 1, 0. This is a big change. So we're saving our data. So that's up to version 3 of the program instead of just the 2s. I just realized I hadn't done that yet. But previously we were asking for an input and just using that, see if there's another, but now we know exactly how many times it needs to run. So I'm going to comment that out. Comment that out. And instead of that while, I'll say for employee in employee data. Or it might be better to work with the indexes here because then we have even, odd, and those go together, right? And then the next even, odd. Since we start at 0, we start with an even number. A little bit different than what we're used to. Let's do the range thing here, and that way we have, so in the range, going from 0 to the length of employee data, and we'll go up by 2 each time. So then the one we're looking at, which I don't want to say employee there, I'm going to go back to I for index. Or I'll spell out the word index, that'll work even better. So the index we're looking at and index plus 1 both go together. Everybody follow that? The order that the stuff was written in the file created a pattern we could follow. And this is what the book's talking about, and they just do it all at once, and you see the finished code. So it's, when you're looking at the finished code, it's kind of hard to see how they got there. Remember, when you're reading through the textbook and stuff, always pause when you get to an example and think about how you would do that. If you try to keep reading through that like it's English, it's not gonna, you're not gonna absorb it correctly. In fact, it'll probably look confusing in a lot of situations because you're trying to read it like English language, but it's Python language. So whenever you get to an example in the book, remember to pause and think about how you would do it, and then compare their version, what they did to what you do, what you would do. There's always lots of ways to do things, and if you just read through and look at that finished version, it's kind of hard to see how they got there. So rate of pay, this line's going to change, so I'm going to hit comment and then shift end to highlight the rest of it, and copy and paste a copy of that right down below. That way I can still get back to it. And hours worked is new information, so we'll have to get hours worked each time. So rate of pay is employee data, and rate of pay is our odd numbers because we wrote the name first. It's perfectly okay to come back up here and check. So name is going to be 0, rate of pay is 1. So we go back around, name is 2, rate of pay was 3. So rate of pay is our odd numbers. So index plus 1 will be the rate of pay for this particular one. And then when we go to print it out, employee name is going to be employee data, the index value. Oh, and this, we need to do math with this now. This is coming straight from the text file, right? So we want to make sure and turn that into a floating point number so that we can do math with it. Because we can't do math with the symbol 3, we can only do math with the number 3. We have to make sure and change those. I'm noticing get inputs only returns hours worked now. So just for some general refactoring, which refactoring means clean up your code. So there was that assignment last week to refactor an earlier thing. And I apparently copied and pasted the wrong thing and didn't realize it. People had submitted that. In another previous semester, when I applied that assignment, I changed it so that I said, choose one of your previous assignments and refactor it into all methods instead of that specific one, because that specific one is probably the hardest one to refactor, right? So you can choose whichever one of your previous assignments you think would be best done in modules and switch modularize and switch it into functions. It doesn't necessarily have to be the sales tax one. Oh, the sales tax one was also that week with positional notation. So definitely make sure the first thing you do is change it back to variables that are possible to work with. Those encoding schemes, if you do it every day at a job, 40 hours a week, you get used to it really, really quick. But we definitely don't have time to get used to it in a classroom. We can move on to the easy to work things. Easy to work with things as long as you're aware it exists. But part of refactoring is making things clean, organized, nicely named. So we're not getting inputs anymore, we're just getting hours. So we get hours and then that goes and asks for it, turns it into a floating point number and sends those right back. Then we put that in a variable and then we pass it in. So we could cut a step out and just ask for it right here. We don't need to put that in a variable if all we're going to do is pass it into the method right down on the next line. So everybody see what I did there? So if I change the name here, we go run that method and we take the return and put it in this method, in this variable name. But the only place we use the variable, you can see from the highlighting, there's no more highlighting down below. The only place we use that is to pass into the method. So instead of sticking that somewhere and then passing it into the method, why don't we just ask for the method that gets us that number where we need to put that number. So then it goes right back to where it needs to be. It cuts a step out of it, but use your own preference because some people just don't like doing it that way. They think their code looks a whole lot better if it's spread out. And we put it somewhere along the way, then we have a meaningful name that can trace your code back. But whichever way makes the most sense. I'm gonna go ahead and put the method name there, mostly as a reminder because you all already knew you could pass variables into parameters or pass variables in as arguments to both parameters. So for our class example, and make sure that you see passing a method in as an argument to fill a parameter. And it's a return method, so it'll return a number and pass that right in. If we wanted to, we could wait till it got back and cast float right here, cast it into a float here. That way it's more symmetrical with this, but there's different ways to do it. So then that, we'll write the latest one to the pay stub, and then we'll be able to look at that file. So this is what needs to happen every time. But now we have something else we could do. So I'm going to put all of this into a function. Define write pay stub. And then I'll just click here and I'll use the arrows and shift key to select everything that happens there. Kind of about there. And with all of those highlighted, I can hit tab and indent them all at once. Put them in that method. Because before that was our main method. That was the main thing it did. But now that's not the only thing it does. This software also fills our database. So we need to put that as our main method. Which instead of writing a main method, I'm going to stick it inside of the guard. So this is definitely not a method, but if we look over here, as we start scrolling down, all of the code to run is indented inside of methods. So we don't actually hit anything that's going to run until we get way down here. Well, there was a variable up above. So this is like the main method. Our textbook always keeps putting things inside a main method and it starts calling that down here. But think of that guard statement as your main method, because that would be the more appropriate way to write the main method in Python. I guess we can do a menu-driven thing now. So when we start, we'll ask, do you want to run the pay stub or enter it in the database? So we have choices, or exit. I guess there's not, we always want to include a quit option in case it was an accident. So we'll start off with a menu-driven thing. I'll say choice is going, that's not how to spell choice. Choice is going to be some sort of input. I'm gonna do a docstring prompt this time. So, oops. Docstrings, putting 3 quote marks in there instead of 2 allows us to include line breaks. So for things like menu driven programming, we can make our menu options look a lot nicer. Because using 3 quote marks will allow us to put line breaks in there. So choice, we'll say, do you I think I need to rewrite these because now they're just starting to sound rude instead of like the original cheerleader prompt. They're not sounding very cheerful. So we'll revamp those later, but they're starting to sound, I guess it's into rude prompts. So we'll stick up our rude prompt. What do you want to do? Then we can say option 1, input 1 to enter data to enter data to the database, add data to the database. Input 2 to run weekly payroll, or input 3 to exit. So we have some nice little choices. And whatever they give us, it should be 1, 2, or 3. So okay, it wouldn't go back to the right indent. So it is Python, so make sure you get back to the right indent level to continue on afterwards. So that gives us a nice little prompt, and then we can see what it is. So if choice is equal to 1, and we want to try to cast that into a number. Actually, I'll do that up here. I was going to add some error handling, but error handling is a big deal next week. So let's leave some places where accidents can happen for now. And we'll talk about error handling in module 5. So if choice is 1, that's add data to the database. So we need to call this write sequential file for code method. Else, if in most languages it's spelled out, but in Python white space matters, so we can't have 2 words for a keyword. Most of our languages have else if as 2 words like they are in English. But white space matters in Python, so we can't have a 2-part keyword. So they just abbreviated it. That's where elif comes from. If choice is equal to 2, we want to write our pay stub. So we'll set up the headers and then loop through that array. Hopefully that's all going to work like it's supposed to. Write pay stub. If it's anything else, we'll exit the program. I'll say pass. And then there's no further code to run after that. We do need to put something there. I guess we could actually leave that one off. But in those spots where we have to put something, and if you don't have anything to put something, pass is the keyword. So pass just means keep going. Something has to be in the else block, but we don't have anything to do in the else block, so we just keep going. I guess if you wanted to, you could print goodbye or something. Is now we run it and see how many typos I made because I was talking the entire time I was typing. And you don't know how it goes. Typos happen when we focus all of our energy on typing. Well, we don't have anything in our database yet, so we better write that. Actually, cancel this. Cancel that run. Because right now I saved that in the same spot. And it's going to write the file in the same spot. Because all I gave it was the file name. If we gave it a full path, it would go look somewhere else. So I want to make a folder to organize this so it doesn't add up to a whole lot of other files. Probably should have done that sooner. Payroll version 3. So I'll just grab this and drag it in here, which is going to cause a problem already over here. Do you want to close it? Yes. And now open that new version. Should have did that earlier, but I just realized that was going to cause problems if we ran it like it was. Okay. Now when we write the file, it will go in that folder, so we don't end up with just lots and lots of files at the top level of the repository. We have a little bit of organization to it. And this is most of the talking after we take a break. The other two types of writing files will go much quicker because this is the ideas we want to look at. Notice how we got multiple lines of input. If I click over here, my cursor's, that's probably not where I want the cursor to be. So I'm going to add one more, just making little adjustments. I'm going to add one more line break there so that the cursor's on the next line and doesn't start way over like that. Those probably don't need to be that far over, so I'm going to bring them back. So just looking at that, I'm going to make some nice little adjustments, and let's try a 1. So is there another employee to add? Yes, obviously. Who is it? Let's say Sally. And how much does Sally make? Sally makes $23.45 an hour. Is there another one? Yes. These do not represent any people. I'm just making up some names. So Bob, maybe Bob makes $19.28 an hour. Yes. Becky makes $22.22 an hour. Yes, one more. David makes $20.75 an hour. Nope, not another one. And then it finished the program. So notice it only did one thing on the time through. So each time we started, it's doing something different. So we could set another loop down in there and add it to our menu to just keep checking if we want to keep doing stuff. But at least for right now, I'm just going to do it one thing on each time through because it only does the 2 things. We're either adding to our database, which we should have now. So if we come over to the folder, there we go. We have this sequential text file. No, I don't want to update. I want to update. And there's Sally's information, and Bob's information, Becky's information, David's information. So we have it stored in a particular sequence. That as the programmers of this software, we know what that sequence is. So when we read it, we can get our data back. That's the big thing. What we looked at last week would just be kind of arbitrarily writing words to a file. And we might not necessarily know how to bring them back into our code because lots of different things were written there. But now we have an order where we can bring them back in. Clear the console here for the next row. If we do number 2, then it should, oh, whoops. before we write pay stub, we better put some data in the employee. We better fill that array, right? So we have it in the database, it's in storage. So we need to read what's in storage in order to do that. So we could either add it here or here. I have a thought on where I'm going to put it. Does anybody see any advantage or disadvantage to one or the other? If we put it down in that main guard statement, or if we actually put it in this method? This method. Any thoughts? We have a Zoom call, have a thought? It really doesn't matter, not many. So yes, I was thinking the same thing. Oh, not at the moment. I thought you said not many. I was reading on the screen across the room. So not at the moment, but what I was thinking is if we put it down here, there's a chance we could forget it when we update our code later, right? For when we go to version 4, we could forget to include that. But we know that needs to happen here. So let's just put it here. And since there's probably more to come, let's take that a step further. So here first thing we'll do is read sequential file. So we'll load it into our array and then work with our array. Actually, I'm gonna take that a step further. Instead of that global array, because that's a place where a mistake could happen, right? We could put extra things in there, read extra stuff in there, double the size of it, or empty things out. It's probably better to work with local arrays. So I'm going to make that a local array. Employee data is an empty array every time we call this. And then after we fill it up, we'll return that. Local scope is always better than global scope. You always want to try to minimize how much your variables exist for. The length of time, the lines of code it crosses. So instead of making that one variable that has an array that lasts the entire file, the entire program, let's make one array that only lasts in that little bitty method. And then garbage collection will clean it up when it's done. And that sends us something back. So then when we get it back, we can stick it into another one with small scope down here. So I use the same name, but they're different arrays. They only have that local scope. And that's another across the board thing you want to consider in software development. Always minimize the scope of your variables. Do as much as you can to avoid global variables. So now we should be able to read that in. Okay, it looks like those menu options are in a better spot. They're not indented quite as far over. There we go. Get the Zoom thumbnails out of the way so I can see it on the screen across the room because I keep looking there instead of the screen right in front of me. What do we want to do? Oh, that's probably why it was acting weird. The doc string does not count as part of our indenting. So I don't want any indenting on that doc string. I want the input to be back all the way over here at the right. But right now it's indented over. So I'll go ahead and fix that formatting. Here, run weekly payroll. Oh, we probably need to see the name, right? We need to know whose hours we're looking at each time through. But we already have that data. So let me cancel this run. I usually just close the tab and spider or something to cancel out of the run or arbitrarily finish it works as well. So when we ask for that, probably need a name passed in. And this one is coming in as a string. So this is, we don't have to worry about cutting digits out or anything. So this is the sort of place where I would use that easy formatting, where we stick an F out front and then throw our variable in there, because we're not going to change what's in somebody's name. We have multiple ways to format it, and we will see multiple ways and usually mix and match depending on the situation. But there are lots of ways to build up a string. Y'all know at least 3 ways already. Whatever makes the most sense in your mind. Give me name apostrophe S as ours, which will be a little bit grammatically correct if somebody's name starts with an ends with an S, because then we should just have an apostrophe instead of a second apostrophe S. But that'll be fine for now. That's a simple selection structure, right? We can just see if the last letter of name is an S, and then decide if we need just an apostrophe or an apostrophe S. But y'all know how to make selection structures, so I'm not going to waste the past time on that. So now let's give that another try. Run this, and what do we want to do? Okay, looks like the format, the input's in a better spot. Could probably leave a couple line breaks there, make it even cleaner. Stick some arbitrary line breaks in so it comes down. What do you want to do? I want to run weekly payroll. Oh, yeah. Now we have to pass that in. Where do we get ours? Ah, right here. So get hours. We need an employee data, the index. This index has our name, and index +1 has our rate of pay. That sequence, the pattern we created. Looks a lot more symmetrical now. Right? Just for symmetry, I would probably move that float from inside of the method to down here. That way it matches the other one very, very nicely. But there's lots of ways to write the code that will all produce the same result. So number 2, got a blank number. That shouldn't be blank. I'm going to print this out and make sure we're reading in the right data. Print employee data. So just adding an echo in. That you always want that to be your first go-to whenever you hit a little bug. Echo out some variables to see what they actually are holding as opposed to what they should be holding. Run that. Number 2. Okay, you got a whole bunch of blank strings. Something went wrong there. Because our file's not blank. You can see there's data in the file. I'm gonna take that out and see what remove that 0. I'll run that again. Oh. Stop the previous run, then run it. And number 2, still blank. Are we seeing the line of the file? So just adding echoes in to see if we see where this falls apart. Oh, well, that's interesting. We only see the end of it on the screen there. We can tell something definitely went very wrong. So read is apparently not the right thing. Read apparently reads one character at a time, and we don't need all that. We need the whole line. So we have read, read one, readable, read all. That's how. Read lines, yeah. Read lines or read all, I think would work here. Cancel that previous run. There we go. And the print looks strange because we have extra things printed out, but it looks like we have index 0, 1, 2, and 3. So it looks like the numbers are coming in correctly. Oh, and then we see Sally, give me Sally's hours. So I'll go ahead and erase those echoes because we know it's reading incorrectly now. So maybe Sally worked 32 hours. Give me Bob's hours. Bob worked 46 hours. Becky's hours. Becky worked 33 hours. And David worked 39 hours. And that finished. So we should have a file that shows the weekly payroll now. Nice and organized. Looks like we got an extra line break in there somewhere. Not that that hurts. Doesn't really hurt our table at all. We might want to track that down. Which should actually be here. If we're getting an extra line break every time. I'm actually going to put this back afterwards because that kind of looked better with the extra line break in there. Spreading out those numbers a little. Or was it down here? Oh, yeah, we printed extra line breaks down here. That's right. Never mind. I was thinking we were reading them in, but I forgot we already, those were there on purpose. I was gonna be like, oh, that extra line makes it look a lot nicer. So a week passes, come the following Friday, we open up the software again, hit number 2. This week, Sally maybe worked a whole bunch. She's making up for that short hours last week. Bob worked right at 40. Becky's hours. 22, maybe she took half the week off, and 38. We come over here and we have the following week's pay. Anybody see something that would be really nice here? Because we just completely overwrote last week's pay. Might be nice to keep that around, right? So, let's put a date in there. Import date. And down here, if we go into number 2, actually, we can do it in the method. So when we write this, oh, that's where we open it. So we open it. Let's paste writer dot write. Well, first off, we'll switch that to a pin instead of write. That way it doesn't erase what's already there. So there's no shortage of storage in our world, right? If you go to cloud services, you pay by, you see a G there, but it's not gigabits, it's gigabits. As a whole lot bigger than gigabits anymore. We're right past dealing with gigabytes and megabytes. If you go buy cloud stuff on the cloud, you'll see the G and the M, but it's Gibby and Millie, or no, Millie's small. Maybe Mibby, Ibby and Mibby with a B. We're way past the giga and mega in our world, and still plenty of room to store stuff. So no need to try to compress storage. There's plenty on the cloud. So let's just add stuff to it. I guess when we come in here, we'll ask what's the date. So timestamp is date dot date. I think that's the one I want. Oh wait, date dot now. Wrong language. Date dot. I think there's a now. That's not going to predict anything. Okay, and then we can print that timestamp. Well, I'll print a couple break. Actually, we'll do this. Copy that. First thing we'll do is print a bunch of line breaks and then a line, and then we'll print out timestamp. So the now one looks kind of funny here. It might be better for a classroom example to ask, but in a real situation, we would just ask that every time. We wouldn't ask, we'd run the payroll on payday, and then it's going to automatically, we want now's date. We don't want to type it in every time. Because we're humans. If we go to type in the date, we have to go look up when it is. I've had to look at the date a couple times today already. Even though I look it up, it's not like I'm going to remember the date all day long. And that is date sort of data, not a string. So we need to cast it into a string to get it right into the file. Oh, maybe not. Oh, paste stub writer is wrong. Paste stub printer. I should have just copied and pasted that. So now, well, it's going to give us a different format on this. I'm going to go ahead and delete all of that was there. I guess I could have just deleted the file. That would have had the same effect. Close the previous room. Okay, the week, we go through the week, get around to Friday, and we run our payroll program. Oh, well, what is the date? Apparently remembering it wrong. Y'all know the process. We can check. Google knows what the syntax, right? Date in Python, W3 schools. Oh, probably wanted date time. Always look at official documentation first, which is probably going to look confusing. And if it, then use a tutorial to learn to read the official documentation. Because tutorials only go so far and don't show the whole picture. So you want to use tutorials to learn to read the user manual. Do I not have datetime.now? Date. Oh, datetime. I think it's, maybe it's datetime. If I go back over here, I can probably pull it from the predicate text. So our module is called datetime. So we'll import datetime. And then timestamp is going to be datetime dot is now on there. I don't see a now. Dot date. Now that's on there. And does that have a today? Ah, datetime dot date dot today. That'll work. Do I have it now? I don't see it now. Today's good enough. Probably should have took a break a moment ago. Sorry. So hit 2 and then enter our numbers, 32, 49, 38, 41. Gives us that file. And we see that it has today's date at the start of it, but kind of in the wrong spot. Might need a line break there. So delete that so we don't have some badly formatted ones. And after we print that, then I'll add in a line feed. Run that to 33, 33, 33, 33. Just to get us up to break time really quick, because we should figure break about 5 minutes ago. There we go. So now we have that in the header each time. And then when we run it again, run enter payroll, we already have our data. Everybody's making up for that this week, 41, 41, 41, 41. And now we have that ongoing record. Right? We have the data to work with. So we can set up selection structures to look for dates in this text file and read this in. And we have ways to retrieve all our data because we know the order it's in, we know the sequence. So that's our basic type of storage. Sequential text file, we create a pattern in the sequence that we write the order we write the data to the file in. And generally you want to do one data point per line, but we can read it back in and then take advantage of that pattern we put up in this, we put in that sequence. Time went longer than I thought. I meant to take a break about 5 minutes ago. 10 minutes sound good? Probably, since we went a little over there. So my clock says 7:21. We'll get back to it at 7:31. And we'll look at better ways to store our data. If I can find the stop recording button, there it is. It's on one of the 4 screens.